Hello everybody, this is Mr. McNair, and this is going to be a short video on graphing linear inequalities. First thing that I would like to go over on this topic is determining whether a solution is an ordered pair to an inequality. For example, here we have the inequality 2x minus 3y is greater than or equal to negative 2. And the ordered pair we're trying to check for is 0, 0. Now remember, every ordered pair is an x, then a y. And all we're going to be doing here is taking those numbers, those values, and plugging them into their corresponding place. So we have 2x, and what is x? X is 0. Minus 3y, y is also 0. And we want to know, is that greater than or equal to negative 2? Now we're just going to simplify. 2 times 0 is 0. Minus 3 times 0 is also 0. And we want to know, is that greater than or equal to negative 2? 0 minus 0 is 0. Is 0 greater than or equal to negative 2? Yes, it is. So therefore, 0, 0 is a solution to that inequality. Let's try one more. 0, 1. Once again, every ordered pair, x first. Let's do a different color. X first, y next, or alphabetically. And then we plug them into their corresponding places. 2 times x, x is 0. Minus 3 times y, this time y is 1. Is that greater than or equal to negative 2? All right, 2 times 0 is 0. Minus 3 times 1, which is 3. 0 minus 3 is negative 3. Is negative 3 greater than or equal to negative 2? No. Therefore, 0, 1 is not a solution. Okay? Great. When graphing inequalities on the coordinate plane, first thing before we talk about that and I uncover those boxes, remember that the coordinate plane is an x-axis and a y-axis. So when graphing inequalities on the coordinate plane, less than or equal to and greater than or equal to signs, those are going to be graphed with solid lines, while the less than symbol and the greater than symbol are going to be graphed with dotted lines. So this one says sketch the graph of x is less than negative 2. A couple things that you should keep in mind. Number one, whenever you have just x in an inequality or an equation, that's going to be a vertical line. And because this is a less than symbol, we know that this line is going to be dotted. So when I graph this, I'm going to go to my x-axis, go to negative 2, and I'm going to make a dotted vertical line through negative 2. Okay? Next, we need to determine where to shade. Okay? The values that are less than negative 2, x is less than negative 2, the values that are less than negative 2 are over here. Okay? So we're going to shade in that region. Okay, so these would be all of the values that are less than negative 2. Anytime you're shading an inequality, you're always shading the things that are solutions. For example, this point right here, this is the point negative 4, 0. Negative 4 for x, 0 for y. If I was to take this ordered pair and plug it in up here, it would be negative 4 for x, once again, is less than negative 2. Is that true? Yes. Now, any point that is not in the shaded region, for example, out here, we have the point 6, 0. If we took that and we plugged it in up here, we would get, once again, x, y, we would get 6 is less than negative 2. Is that true? No, it's not. Everything that's shaded is a solution. Everything that's not shaded is not a solution. Here, similar. This time we're dealing with y is less than or equal to 1. Looking at that, you should realize that anytime you have y solely in an inequality or equation, it's going to be a horizontal line. And because it's less than or equal to, there's going to be a solid line. A lot of times I think of it being a solid line just because in the symbol, less than or equal to, you have a solid line under it already. So it's kind of obvious. That's a little mnemonic device you could use. So we're going to go to 1 on our y-axis, and we're going to make a horizontal solid line through that one. All right, great. Now, the values that are less than or equal to 1 are the values that are below that. So we're going to go ahead and shade below that. So here's our solution set. Okay? All of those values. All right? So, once again, anything that's shaded, anything that's in this region, these are all solutions, while things that are not in that region are not. All right. Now, we're not always going to be dealing with vertical and horizontal lines. Sometimes we'll be dealing with oblique lines. Two ways to determine where to shade when dealing with oblique lines. First way, you could put the inequality in slope-intercept form. If it's in slope-intercept form and you have less than or equal to, you would shade below the line. Okay? And I think of shading below the line as this. If you imagine your line is a hill, shading below the line is like shading the street or the grass. Okay? Other way, if you have a greater than or equal to sign, you're going to shade above the line. All right? There you go. If you imagine your line is a hill, shading above the line is like shading the sky. Okay? The second way that you could determine where to shade your oblique lines is pick a point not on the line graphed. If the point makes the inequality true, meaning you plug in the values of that point and everything in the inequality is true, everything on that side is a solution, therefore you shade that side. If the point makes the inequality false, nothing on that side is a solution, therefore you shade the other side. And we're going to show you some examples of that. So here, 2x plus y is greater than 3. A couple things that you could do to start graphing this. Number one, you probably want to go ahead and put it in slope-intercept form. So slope-intercept form has y by itself, so we're going to subtract 2x from both sides. Those cancel out, leaving you with y is greater than negative 2x plus 3. Now y is by itself, so we know that the y-intercept is 3, and the slope is negative 2 over 1. So our y-intercept, 3. Y-intercept goes on the y-axis. Our movement to make other points would be down to right 1. Down to right 1. Or you could also go up to left 1. Now, before you just connect the dots, remember you have to consider dotted or solid. This is going to be a dotted line because it was a greater than symbol. All right? So we're going to connect the points here with a dotted line. I apologize for my line not being the straightest. All right. Now, let's cover the two ways that we could possibly determine our shading. Here, we see while y is by itself, that y is greater than or equal to negative 2x plus 3. So therefore, since it's greater than, we shade above. And this would be the stuff above the line. Okay? The other way that we could have picked that is pick a point that's not on our line. Usually the easiest point to pick, if it's available, is the point 0, 0. That's not on our line. If we plug that in to the equation, either the beginning equation or even the rewritten equation, it doesn't matter, and it comes out true, then it is a solution. So let's see. I'm going to plug it into the original equation because that's usually a little easier. 2 times 0, that's 0. Plus 0. Is that greater than or equal to 3? Well, is 0 greater than 3? No, it's not. So therefore, this is not a solution, and therefore nothing on this side would work. Everything on this side will work. Everything on the shaded side will work. Okay? And you could choose which method you decide that you want to determine where to shade. Next one. Let's try one more here. So, negative 5x minus 2y is greater than negative 2. I would go ahead again and put this in slope-intercept form. So we're going to add 5x to both sides, leaving you with negative 2y is greater than 5x minus 2. To get y by itself, you have to divide by negative 2 and do that to everything. And this leaves you with y is, careful here, less than, because remember, when you multiply or divide by a negative, you have to flip the inequality. negative 5 halves x plus 1. So the y-intercept is 1, and the slope is negative 5 halves. So y-intercept is 1. We start there, and then our movement from that 1 is down 5. 1, 2, 3, 4, 5 over 2. Or we could have also went up 5. 1, 2, 3, 4, 5, left 2. Again, we're going to connect this with a dotted line because it's just a less than symbol. So connect with a dotted line here. And because this symbol is a less than, remember, it has to just be y by itself. Because that's a less than, we shade below the line. So shading below the line in this scenario would be here. This is all the stuff that's below the line. Okay. Again, you could have picked a point that's not on the line. Like here, 0, 0 is not on our point again. Excuse me, it's not on our line again. So if I would have picked 0, 0 and plugged it into the original equation, the left side would have become 0 because 0 times anything is 0. Is 0 greater than negative 2? Yes, it is. So that's the side that has all of the solutions. All right. Last example. Sarah can spend at most $7.50 on vegetables for a party. Broccoli costs $1.25 per bunch, and carrots cost 75 cents per package. Write a linear inequality to describe the situation, letting x represent broccoli and y represent carrots. So we know here that broccoli is $1.25 per bunch. So it's $1.25 for each bunch of broccoli, plus 75 cents for each package of carrots. Now, Sarah can spend at most $7.50. When I say that I'm going to give you at most $7.50, that means I'll give you $7.50 or less. So that's going to be less than or equal to $7.50. So that would be the inequality that describes that situation. Now, to graph that inequality, here it is. You can graph it in a couple of ways. You can put these in slope-intercept form. I personally, however, like to graph these using our intercepts. And we talked about that before. Using the intercepts, all you have to do is the cover-up method. If you cover up the y and then say, okay, well, $1.25 times what value gives you $7.50? Well, $1.25 times 6 gives you $7.50. So we know that the x-intercept is 6. We can find the y-intercept by covering up the x. 75 cents times what value gives you $7.50? Well, 70.75 times 10 is $7.50. And because we have a less than or equal to, because it's an equal to, we're going to connect that with a solid line. Again, you can pick a point not on your line to determine where you shade. 0, 0 makes an effective point. So you would get 0 on this side is less than or equal to $7.50. And that is a true statement. So we are going to shade below the line here. All of the stuff in here. Okay. And there you are. Hopefully this video was helpful to you, and have a great day.